Hey, Mr. Riley here with the start of Unit 3, which is going to be operations with rational numbers. Talk about that a little bit in the next topic. We're going to start with a discussion of fractions and decimals and how we can equate those two things. So this should be mostly review, I think, in looking at fraction and decimal equivalents. We start on page 94. So any fraction can be written as a decimal, and any decimal can be written as a fraction. Okay, so some of them are easily converted to decimals by changing the denominators to a 10 or a 100 or a 1,000. So those are kind of friendly numbers like a 2, a 10, a 5, a 20, a 25. Those numbers as denominators you can multiply to get to 100 and then multiply the numerator to get to 100, and that will give you the decimal, or a factor of 10 rather, to a 10 or 100 or 1,000. Okay, so that's one way to do it. But any fraction can be, as long as the denominator is not 0, it points out, because that makes your calculator explode. Okay, so you can't divide by 0. But as long as the denominator is not 0, any fraction can be written as a decimal by dividing numerator divided by denominator. Remember, every fractions are really division problems anyway. That's what the fraction bar means: divide the top divided by the bottom. Okay, and so they can come out into two different types of answers. You can end up with a repeating decimal, or you can end up with a terminating decimal. Okay, so they talk about that the decimal form of any fraction is called a repeating decimal. But you're not going to think of it as a repeating decimal if the digit that repeats is a 0, right? If the actual non-zero digits stop, that's what we call a terminating decimal. Terminating meaning stops, right? If something terminates, it stops. The terminator, he killed his target, whatever he was. So John, what's his name? Can't remember. Anyway, so some fractions will stop and some fractions will not. And we'll look at both of those here today. Okay, so the example problem here, write 7/8 as a decimal, and they go through, let's use a paper and pencil and practice long division. I'm really not interested in practicing long division. You did that in 5th grade and maybe 6th grade, and you don't need to practice that anymore. If you don't know how to do long division, it's not that big a deal. You have a calculator. So you have to understand how long division works, but we'll use a calculator for all of these. So you do 7 divided by 8, numerator divided by denominator, and your calculator spits out a 0.875. Okay? So let me just point out to you that I don't care personally if you put a 0 in front of the decimal point. I don't know if we've had this discussion before. Okay? I personally do not require the 0 in front of the decimal point. If you just wrote 0.875, you get full credit from me. Now, future math teachers might not feel that way. Some math teachers think it's really important to put the 0 there in the ones place in front of the decimal point. I do not. So if you don't include the 0, that's no problem for me, because most of the time when I write my decimals, I don't put the 0 in there. Okay? All right, so 4/5 as a decimal, 0.8, 4 divided by 5. 3/16 as a decimal, 0.1875. Okay? Now, with no rounding instructions, okay, if they ask you what is the decimal equivalent of this fraction and there's no rounding instructions, then you got to write the whole thing. If it's 8 digits, you got to write all 8 digits. Otherwise, if you cut any of those digits off, you're actually rounding off the decimal, or you're making an approximate answer to what that fraction is. Okay, the exact answer goes as long as the decimal goes, then it's exact. Okay. Now, of course, the second type of problem is when the decimal doesn't end. Okay, these are called repeating decimals. Okay, and a pattern that repeats, it can be one digit that repeats, like the very common ones of 1/3 and 2/3. Okay, or it can be any number of digits. You could have a repeating decimal that has 80 digits that repeat, and then 80 digits that repeat again. That's going to be a very bizarre fraction. Okay, I will point out, though, and I'm kind of happy the book does this. First off, let's look here. So 1/6, okay, 1/6 as a decimal, you do 1 divided by 6, and they show you here in your long division, Then when you do that, you keep getting this same pattern. So it just keeps going 6, 6, 6, 6, 6, 6, 6, 6, 6. Okay. Then they say, oh, check it by using a calculator. If I have a calculator, why am I doing long division in the first place? But okay. So in a calculator, your calculator is going to give you this answer, 0.166666667. Most calculators will give you the answer that looks like this. Be careful. This last digit of the display of the calculator, the last digit on the display of the calculator is rounded off. Okay. So however long the calculator display is, typically the last digit will round off. It's like this calculator, which maybe you can see. We'll find out when I edit the video. 1 divided by 6. And so it rounds off at that last decimal place. It looks to the next place after the display. If it's 5 or above, it rounds up. Okay. So sometimes it looks, and for advanced math students, this shouldn't be a problem. For regular math students, they see this 7 like, oh, it's not a repeating decimal. The last digit is different. No, it's rounded. Okay. It can be especially complicated when you get to longer patterns of repeating decimals. Okay. So down here, it talks about some different types of repeating decimals. What the digits that repeat, okay, the best way to write these, the accurate full way to write a repeating decimal is with a repeating bar. We're using bar notation. So the bar goes on top of the digits that repeat. In this case up here for 1/6, the bar goes just above the 6. Make sure it doesn't go above the 1, because if it was above the 1 and the 6, it would be 0.1616161616, which is a totally different number. Okay, it's actually 16/99, the fraction that is 0.161616. Okay, but so if it's just the 6 that repeats, the bar goes only over the 6. If it's 2 digits to repeat, the bar goes over both of those digits. If it's sevenths, okay, like this one down here, okay, when all your sevenths are all 6-digit repeating decimals. Okay, I don't know what they are. I just know that when you do something of sevenths, the answer is a 6-digit repeating decimal. And so the bar goes over all 6 digits. And if your calculator went beyond here, it would do 714285, 714285, 714285, 714285. But at the end of the display, it's going to round off that number. So it's kind of hard to see for this one. Let's see. I don't know what that is. It's probably 5/7. Let's see. 5 divided by 7 is nope, I was on one. Yeah, 714285. Yeah. So you'll see on the calculator here that it says 0.7142857143. Oh man, there's an extra digit there. It's not repeating. No, it is repeating. Okay. It's just rounding off at the last digit, but it'd be pretty hard to find this repeating pattern if you didn't know it. If you didn't know it was a 6-digit repeating pattern. Okay. And actually, there is a fraction that actually is this terminating decimal. If it stopped right there, that would actually be some fraction. Okay. I can quickly use the trick of this calculator, which has a decimal to fraction button, and let's see what it does. 5/7. Oh no, 0.7142857143. And if I want to convert that to a fraction, the answer is, oh, it's rounding off. It thinks it's 5/7. I outsmarted the calculator. Okay, so much for that. I'll probably edit it out, or maybe not. Okay, moving on. So anyway, very frequently, like lots of fractions end up as repeating decimals. Any fraction that's divisible by 3, right? If it has a factor of 3 in the denominator, those tend to give you repeating decimals. So, all right. So example number 2, write each fraction as a decimal, use a bar, okay? So it's not asking you to round off the answer. It's telling you to use bar notation to answer the problem. Now the book, of course, goes through, oh, here's long division, blah, blah, blah. And to that I say, use a calculator. 5 divided by 12, you get 0.4166666667 at the end of your calculator display. So it's 0.416, and the 6 is repeating, just the 6, okay? So negative fraction, right? A negative fraction, the equivalent of a negative fraction is a negative decimal, okay? So if there's a minus sign in the front, just make sure there's a minus sign of your fraction. Make sure there's a minus sign in the front of your decimal. 2 11ths. 2 11ths is 0.181818181818. All right? So 2 for you to do is got it. Negative 5/6 with a repeating bar. Not so easy to put a repeating bar in an Edpuzzle answer. I don't think you can, actually. So what you could do then is use an ellipsis, right? That's what this is. These 3 dots that mean and so on forever, right? That's called an ellipsis. And if you can't, you write a repeating bar because word processing prohibits you from doing that. You can always do the ellipsis, but make sure that you show enough of the repeating pattern so that you can tell what is repeating, okay? You wouldn't want to write 0.416 ... for 5/12, right? If you did that, you wrote this 0.416 ... that to me would imply 0.416416416, right? Which is not what we want. So you have to make sure if you're going to use the ellipsis, right, that you provide enough of the repeating pattern so that it is obvious what things are repeating, okay? Negative 5/6. And that would be 0.83 repeating, 0.83 repeating. Or with an ellipsis, you would write 0.8333 ... Okay, that tells you it's the 3 that's repeating. 7/9. Some of you might know the trick for converting ninths, fractions of ninths into decimals. It's a very clear pattern, which we will talk about here in a second. 7/9 is 0.7 repeating, 0.7 repeating, or without a repeating bar, 0.77 ... like that. Okay. So there are some fractions and decimals that you don't want to be using a calculator for to figure out what they are. You should know them, okay? These, in my experience with regular 7th and 8th grade students, this is the list that we expect them to know. Quarters, halves, thirds, fifths, tenths, okay? So you should be able to know all of these. I'm not going to Edpuzzle question all of them, right? Quarters, half, 3/4. 1/3 and 2/3, these are ones that trip lots of people up, but not accelerated students. 0.3 repeating for 1/3, 0.6 repeating for 2/3. Okay, so thirds are always repeating decimals. Fifths, okay, well, each fifth, this is one that multiplies out to 100 to get a decimal easily, right? That 5 times 20 is 100. So if you multiply the top by 20, that gives you the hundredths, right? So 1/5 is 0.20, 20 hundredths. And each fifth is then adding 0.2. So it's 0.2, 0.4, 0.6, 0.8. Those are fifths, okay? And then tenths, well, 1/10 as a decimal is 1/10, 0.1. 3/10 as a decimal, 3/10, 0.3, right? So it's actually the official way that you say 0.3, right? There's some teachers and some math people that don't like you to say 0.3, okay? Instead, they want you to say 3/10 or 30 hundredths in this case, which is the same thing. Got rid of that thing. I'm personally fine with saying 0.3. It's what I always say. I don't say 3/10 typically, but the official math way to say this decimal is 3/10, just like this fraction. 7/10 and 9/10. The reason there's 2 digits here is because typically we take this and we go to the next step, which is what are these as percents, and that's why you have the zeros in there. But we'll talk about percents in a future unit. All right, so now there's some fractions maybe that you might know, okay? And these are ones that show, oh, I didn't even keep these covered up down here. So eighths. Okay, so a lot of times we get things split into eighths because you split something in half, then you split those in half again, you get quarters, then you split quarters in half again, you get eighths. And so eighths are half of a quarter. Okay, so that means each eighth is 1/2 of 0.25. Okay, or half of 25, and half of 25 is 12.5 or 12.5. So 1/8 is 0.125. 0.125 is 1/8. So 3/8, I don't have 2/8 because that's the same as a quarter, right? But 3/8 is 0.25 plus another eighth, plus 0.125, 0.375. 5/8 is 0.5 plus an eighth, half plus 1/8, 0.625. And 7/8 is either 1 minus 1/8 or 3/4 plus 1/8, right? So 0.75 plus 0.125 is 0.875. These are good ones to know. Do you have to memorize these? I'm not going to take time to make you memorize these, but it's helpful. The more of these things you have memorized, the less you have to go to your calculator. And of course, the smarter you look when you can do that with other people. 20ths. 20ths is another one that's easy to make into hundreds, right? Because 20 times 5 is 100, which means that I multiply the numerator times 5 to get the hundredths. So 1/20th is 5 hundredths, 0.05. 3 times 5 is 15 hundredths. 7 times 5, 35 hundredths. 9 times 5, 45 hundredths, and so on. 19 20ths, that's 1/20th less than a whole. So that's going to be 95 hundredths, right? Each 20th is 0.05, 5 hundredths. Sixths, I don't know my sixths. I kind of can think about it as half of 0.3 repeating is 0.16 repeating, I think it is, right? And but I don't really memorize these. But you do see them pretty frequently. Sixths are not that uncommon. 0.16 repeating for 1/6. You don't need to worry about 2/6 or 3/6 or 4/6 because those all simplify to easier fractions. And 5/6 then is 0.83 repeating. The last two are pretty easy patterns to see. Ninths are really simple. Ninths are just the 1-digit repeating. 1/9, 0.1 repeating. 2/9, 0.2 repeating. 3/9, 0.3 repeating. Why isn't that in there? Because 3/9 is the same as 1/3. They are equivalent fractions. So 0.3 repeating, 3/9, and so on. 11ths. What is the pattern here in 11ths? You should all, as advanced math students, be able to see this pattern pretty easily. 1/11th, 0.09 repeating. 2/11ths, 0.18 repeating. 3/11ths, 0.27 repeating. 4/11ths, 0.36 repeating. 5/11ths, 0.45 repeating. Where does this number come from? It's 9 times the numerator, right? 9 times 1, 9 times 2, 9 times 3, 9 times 4. So all 11ths work that way. So you can even really memorized your 11ths fraction to decimal conversions, okay? Again, how important is it that you be able to do these things? Well, if we had more time, we'd drill and kill and practice, and I would give you this memorized test on fraction decimal equivalents. I'm just going to leave that to you. I'm not going to test you on it, okay? But certainly without a calculator, you should be able to do all of these without a calculator, and maybe eighths. I wouldn't probably, and 20ths. Okay, but that's because you can get what those are. Use another tool. You don't have to memorize them. Figure out the pattern on where they come from. That's what advanced math students do. The book just lists these on that page, which is a pretty feeble list. So, but anyway. All right. So a couple of real-world example things. We use real-world fraction to decimal conversions all the time. You probably hear them every day if you're a sports fan, especially. Okay, so here's an example there. A teenage boy is supposed to consume 2,700 calories every day. 360 of them should come from milk. To the nearest hundredth, so that's rounding instructions. To the nearest hundredth, what part of the teenage boy's total calories should come from milk? 360 out of 2,700. So that's the fraction, 360 over 2,700. You could lop zeros off of these when you put them in your calculator if you want and do 36 divided by 270, but it doesn't matter. You'll get the same answer. You put it in your calculator, you get 0.133333333. Okay? So when you're given instructions to round, because we typically don't report real answers, real world answers with repeating decimal bars, right? It's like, well, approximately how much is it? 0.13 repeating. Well, it says to round to the nearest hundredth. That's 2 decimal places. So 0.13, and look at the next decimal place. It's less than 5, so it stays as 0.13. Okay, that's all this discussion there about round down because it's less than 5. Hopefully you're all okay with that. Okay, so the answer to this problem is 0.13. Milk should be 0.13 of the daily calories. Here's one for you. The recent Masters tournament, Zach Johnson's hit the fairway. Okay, his first shot landed where it was supposed to in the short grass, 45 out of 56 times. Okay, so to the nearest thousandth, what part of the time did his shot land on the fairway? The answer is, well, we're going to do 445 divided by 56. Put in your calculator, you get 0.80357142286. It's still going. Hey, I don't really know where this stops. This was the end of the calculator. All right. But you have rounding instructions, which you have to pay attention to. Okay. In real world problems, typically they're going to give you rounding instructions. So this one says they want it to the nearest thousandth. So let's see, that's going to be the third decimal place, tenths, hundredths, thousandths. We look to the next one. It is bigger than 5, 5 or bigger. So we're going to round up, and the answer is 0.804. If you don't write the 0 in, that's okay. 0.804. Okay. Now, you very rarely hear this number read like this in sports. Okay. In baseball, you would. If this was his batting average, they would say that this guy's batting 804. Okay, if he had 45 hits out of 56 at-bats, which would, of course, be ridiculously phenomenal in baseball because most people in baseball hit about 300. The best hitters hit above 300. Okay, this would be 804. Okay, normally this is will be reported as a percent, which we'll obviously talk about when we get to the unit on percents, which is coming up after this one, I think. All right, finally here, comparing fractions and decimals. So sometimes you're given one number in one format and another in the other format, and you're like, which one is bigger? Is this bigger than that? And in order to do that, put them in the same format. It is typically easiest to put them both as decimals, especially if you have a calculator. Make them both into decimals, then you can see which one is bigger or smaller by comparing each decimal place. Okay, so 1/4 and 0.2, which one is bigger? Okay, or is it greater than, less than, or equal to? 1/4 then we'll make into a decimal without a calculator because you know what that one is, 0.25. So 0.25 compare with 0.2. If they're different numbers of decimal places, just add zeros on the end until they match up, right? That's what you have to do. And then you look at each decimal place. So in the tenths place, these are equal. They're both 0.2, both 2/10. But then in the hundredths place, this side is a 5 and this side is a 0. Meaning that 0.25 is greater, so you use a greater than sign. Okay, and they show you, oh, see, on the number line, 0.25 is to the right of 0.20. It's greater. The reason they did this is because when you talk about negative numbers, you have to be careful, which we will do here in the next example, I think. Yep, sure enough. -5/8 and -6/9. -6/9. I would just write that as 2/3, and then I know 2/3 is 0.6 repeating. When one of these is repeating, you have to write out the digits as long as you need to in your decimal so that you can compare. Okay, you couldn't just say 0.6, right? Because that would be the same as this one. 5/8 is 0.625, 6/9 or 2/3, 0.666. So in the tenths place, they're the same, but in the hundredths place, this one is larger. However, these are negative numbers. So remember that the larger the absolute value for negative numbers, the smaller the number, because it is further to the left on the number line. So negative numbers go backwards when you are comparing them. So 0.666, negative 0.666 is smaller, less than negative 0.625, right? So that means the answer here is a less than symbol. I'm sorry, a greater than symbol, okay? All right, 2 for you. 7/8 or 0.87. What symbol goes under this box? Greater than, less than, or equal to? 0.875, 0.870, add that on there, right? So in the thousandths place, the 0 is smaller than the 5, so it's a greater than sign. Okay, for B, negative 7/15 or negative 5/12. What goes in this symbol? Negative 7/15 is 0.46666666, or negative 0.46 repeating. But again, when we're comparing, putting a repeating bar over here doesn't really make a lot of sense because I got to look at the digits to compare them. 5/12, 0.416666. So in the tenths place, they're the same, but in the hundredths place, this one's a 1, this one is a 6. This value, absolute value, is larger, but these are negative numbers, meaning that this number is actually to the left on the number line. It is less than this. So negative 7/15 is less than negative 5/12. And that's it. So we'll have some practice problems on these. We'll look at the guided practice maybe in a separate video and go from there. This should be pretty straightforward, very simple. Divide numerator by denominator in the calculator. Understand terminating or understand repeating decimal notation. Be careful when you're comparing negative numbers, and memorize or try to get as many of those fraction and decimal equivalents. You should know some of those.